run చేస్తాం.
ఇక్కడ మనం
Zoom meeting काय त्याचं చెప్పండి వాడు కూడా అంటున్నాడు ఏమేమో ఆరెంజ్ రావట్లేదు
Hi guys, good evening. Varun, are you present in the session?
இந்த வாய்ஸ் பண்ணிடுறேன்.
Hello guys. Sir, Surya Prakash sir, are you available?
Yes, 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 I'm available.
Yes, sir. Yes. Guys, today we'll be starting the second day of embedded systems workshop. Hope it is knowledgeable and you learn good things over here. Yeah. So we can go ahead with the session, sir. Guys, are we audible? Can I get a yes in the chat box? Okay, thank you. Sir, I can see your screen.
Yes, yes, I'm just joining through my mobile.
Okay.
Can you hear me? Yes.
Yes, sir, we can hear you.
So I want actually please allow my mobile also. There is a mobile screen.
Done, sir.
Yes, yes. So right. So here Now I can able to. So the thing yesterday we have deal like we have seen regarding the Arduino. So here you can see in my mobile view, this is the physical board that we have seen. So yesterday we have seen this simulation here, and today we are going to same perform the same work what we have done yesterday. So there is a slight difference with the simulation board and the board that I have right now. So actually, this is just another variant of the same UNO board. The only thing is like this IC. So here you have this IC, and here you have this SMD type IC. So these are the only two difference, and rest everything is same. Like you can see the same. Here you have the same analog inputs, same digital inputs, and here above you will have the power supply, and that's it. So same analog, and here you have the digital, and then at the bottom you're gonna have here. So these are the power supply, and these are the analog things. And here you're gonna have the digital. So let's have a, demo like LED example now. So just a minute, I will just I'll just make the connection, and let me see first. So let's recall what we have learned yesterday. Chapter cat, circuit. Let's do this. So here, like and two terminals to connect to the digital pin, and using the same code what we have right now here. So what is the code we have written here? Using the same code, we need to control the LED. So we need to perform this physical task using this Arduino board. So just a minute, I will just have the same connections in using this board, and again I will start my camera. Alright, actually OLED, OLED ITC కదా చెప్తాను. So I got some jumpers here. right? So in for practical purpose, we are going to learn regarding this. So this is the mega version of Arduino, and the thing that you have seen here is the seen before is the Arduino Uno, that is the mini version, and this is the Arduino Mega. So this has many, this has the same similar operation, similar to the Arduino UNO, but it has more pins and it can compatible with multiple, like more number of sensors connection and more number of pins handling than the any other board. So that is why it is called as Arduino Mega. So here you have the same functionality here, but coming to here you will have more digital input output pins along with some special pins here. So starting from here, you're gonna have the same kind of Arduino UNO pins like 0 to 13 digital input output pins. But below it has some other special ability pins like special purpose pins like SCL, SDA, and here you're gonna have extra digital pins. And at this point, you're gonna have the analog pins. And here from starting from here A0 to A7, A8, AN, A10, A11, and up to A11, A12, A13, A15. So starting from A0 to A15, total 16 analog pins. It has 16 analog pins, and the digital pins is like 0 to 13, 14, 15, 20, 21, 51. Total 51 digital pins. So 51 digital pins, and here you're gonna have 16 analog pins. And same, the power supply unit is same like 5 volts, like 5 volts and V in, and 3 ground, and 3.3. Everything is same like the audio, the USB jack. You can see the USB jack. So this is how the USB jack type looks like, and this is the power jack. And using this USB jack, you need to upload the code. So simply this is Arduino Mega. So now we are going to handle yesterday's example with this board. So let's go. అరే ఒక ఎల్ఈడి రా ఒక ఎల్ఈడి ఉంది రెస్టర్ ఏవా మరి ఏంట్రా మేల్ ఫీమేల్ So here we are using pin number 8 and then ground, and here we have these LEDs here. So let me use that. Let me connect it. Yesterday we have connected pin number 8 and the ground pin. So the same way we need to connect same the positive side of the LED should be connected to any sensor digital pin or signal pin like digital pin, and the ground should be connected to the ground through a resistor. So, so let's see. Here we have the board like, so you see here. Here we have connected to pin number 8, and then here we have connected to the ground. So without confuse here, so that what I'm doing, I'll just count from the beginning like 8, 9, 10, 11, 12,
Sir, in a few. Guys, you will be able to listen Sir's voice in few minutes. He has got some network issue.
So, can you hear me? Just please confirm that. Can
Sir.
you hear me?
Yes, sir,
Okay.
we can hear you. Go ahead, please.
Okay. So there is a small problem between my mobile network and system. So just I exit it. So here you can see that we have two LEDs, and here we have connected to the sensor. So and here you can see that I have connected these LEDs through breadboard. So this is the positive terminal. So here I have connected the resistor, one end of the resistor here in the same line, and with this resistor I have taken it to the next level, and from here I have connected two LEDs positive terminals here, and the two LEDs negative terminal is connected to the negative or the ground pin. So here this is connected to the ground pin. So now let me power it up, and let's write down the code. So now I'm stopping the streaming.
Sir, you're not audible.
Oh, sorry. Here, before the void setup in the code, we need to start with the data variable declaration, like along with the data type. So here, data type is int, and variable name. Let's say we are performing a LED example. So let's take the pin that is connected to an LED is also named as LED. So int LED pin. So let's say LED pin I have taken as 8. And in void setup, as we discussed yesterday, we need to set the type of the or the status or the mode of the pin that we have chosen. So we have chosen 8, and the mode of the pin should be like output. It has to give something out so that LED can able to receive that data, and based on that, LED can turn on and turn off. And yesterday itself, we have seen that how come an LED, an electronic device, understand the binary information. So the term 0 refers to the voltage level 0, and the term binary term 1 refers to the voltage level 5. So let's say pin mode. So what is the pin mode here? So this is the pin mode, LED pin. comma, and what is the type of this pin? It's output. And then next we'll go for, we need to blink the LED, right? So digital. So digital, right? What is the first one? Pin number, LED pin, comma. We need to print the output, or we need to give the output. So I am giving as high. That is 1 GH. High. And delay for 1 second. And next again, we need to turn off the LED for another 1 second. Turn off, like make it low, and wait another 1 second. Another 1 second. So now we need to plug in the board. So I'm just connecting the USB. So I'm just turned on my, so I have connected the USB here. So I have connected the USB. So just plug in the type B USB here. So then the other end I need to connect to the system. So I'm just connecting it to the system. And once I have done that, you can you heard, like, let's see, go up here, and let's first set the first point to be like, the first point should be like, you need to go to tools and to select your board. You need to choose the appropriate board here. So what is our board here? So our board here is, it is Arduino Vega. So let's go here and check out this. There is a board called Arduino Mega here. So in the Arduino AVR boards, we're gonna have Arduino Mega and or Mega 2560. So ours is Arduino Mega. Just select Arduino Mega, and the next step is you have to select the port. So what is the port? So I have connected, and it is selected as port number 67. Just we need to select this. That's it. So we should not try with any other settings. So here you have Arduino Mega and Arduino Mega 2560 on COM port 67. So after that, if you want to check for any errors, just hit compile. It will compile the code and check for errors. Like, say, if you have errors here, just click on compile. So here you see the code is getting compiled at the bottom section. And once the compilation is done, if there are any errors in the code, it will show up the errors, and I have voluntarily made an error. So, right. So you see an error expected semicolon before the flower bracket token exception. Like here, there is an error here. At that point, it is expecting a semicolon. There we have missed that semicolon. So in this line, that's a semicolon. So this semicolon, and then it compile. Now there should not be any kind of errors. Right. So if we done compiling, and it also given some of the basic information that we space that occupied, space that occupied by the, yes.
Sir, your audio is echoing, sir. Can you set the audio settings once? Check the audio settings. It's not.
Okay, one. Just a minute.
Hello. Yes. So okay. Now I think you can able to hear me, right?
Yes, sir.
Yes. Yes. Okay. So okay. Let's continue. And here you're gonna have some. Okay.
Sir, there
You're
is some echoing, sir.
yes, yes, yes. Just that due to my mobile, I have done reducing the volume of my mobile. So the
You can
sketch. Uh,
you can leave the audio in your mobile and then then continue. That-
yeah. Yes. Now it is okay, ma'am.
Yes, sir. Perfectly fine.
Okay. So here we have, so here the compilation also tells about the size of the sketch. So it is around 1548 bytes, not even 1% of the program space. And the maximum space that is allocated for Arduino Mega is 22,53952 bytes. So here it should not be greater than some around at least 70 to 80%. We should not exceed the program percentage, like it should not be greater than 70 to 80%. So then, because the other 20% is allocated for the performance of the device. So if we completely use all the storage, then it may affect the performance of the device. So let's upload the code and let's run it. So just we have done the compilation, and if you click on upload directly, it will first compile the code and then it will upload to the code. So let's do that. I'm clicking on upload. So it is uploading and it is uploaded successfully. And I will just turn on my video camera again. And now you see the LED is being toggled. So you can able to see that LED is toggling successfully. Now what I'm trying to do, I'm just reducing the uh, time delay, like blink for 500 milliseconds and yeah, blink for every 500 milliseconds. So turn off for 500 milliseconds and again turn on for other 500 milliseconds. And just uploading the code, you can see once the code is uploaded, you see the blinking is very fast than what you see right now. So it is uploading and uploaded. So now you see it is blinking very fast. And again, I'm uploading with much more reduced delay. Again, it is compiling. For every, if you want to upload the code, then you have to make changes. And before uploading code, you have to like a mandatory point is like before uploading code, you have to compile it directly. So you see, it is blinking very faster than again for the second trial. Compared to second trial, you can see it is blinking much more faster. So this is the LED example, and this is how we usually deal with the digital things. And the most important part you have to consider, like if you make any kind of mistake at this sensor pin, so that is fine, it's okay. But if you make any mistake at here, at the point where you handle this power supply, so that is the point where all this damage to the board happens, and we can even reset by using this reset button. So if I click on this, you see again it stops and then again continues. So click on again, stops, again reset. So this is the reset button functionality. Right. So let's move on to the next example. So the next example is communication protocols. So here communication protocols are, so the first one is UART communication protocol. So coming to UART communication protocol, we use that in our every day-to-day life. The best example of UART communication protocol is the data cable that we use for our mobile phones. So the at present we have Type-C port, but before we're gonna have micro SD port. So in this micro SD port, you're gonna have four wires, like four pins. So those pins are 5 volts, ground, TX, and RX. So only four pins will perform the UART. So in the same way, we have an example here. Okay, this is one Arduino, and this is another Arduino. First of all, we need to understand why we need to use this communication protocol. Because if you want to exchange information from one device to another, there is no direct method like you can just transfer from here to here, because this board does not have any kind of wireless networking system. So that is why we need to go for any wired communication system. Here we are establishing the first communication protocol, that is UART. In UART is nothing but universal asynchronous receiver and transmitter. And the best example that we're gonna understand about UART is your data cable, especially the micro SD cable. And even the C cable that we are using right now is also same time which enhances or utilizes this UART protocol, UART communication protocol. So you see here in we have two Arduinos, and in these two Arduinos, the ground is connected and to the another Arduino ground. So which makes it common. So because this Arduino has another supply and this Arduino has another supply, both has individual supply. Then now if you want to make both under common supply, you need to make their grounds common. So do not common their positive supply or positive pins. Instead, only make the ground common. So this ground is commonly connected to this ground. So now both, even though they have individual supply, but both supply level is at same connection, because we have connected both, or we have shorted both of their grounds. And then here you see, if I zoom in, so you see this is the TX pin and this is the RX pin. So from here, from TX, the data is transferred from this Arduino to this TX to this Arduino at RX. You see the TX of Arduino to this Arduino, the TX of this Arduino is connected from here all the way to the RX of the first this Arduino. And again the TX of this Arduino is connected back to the RX of the second Arduino. So in this way, every UART communication protocol has sweeped pin connection. Like you need to sweep their connections like TX to RX and RX to TX. So from here, the data is transferred to this device through this TX RX pin, and from here, the data is transferred from the first Arduino to second Arduino through this wire, or this TX to RX jumper or wire. Okay, and let's watch out the code. Right. So here we are dealing with the another data type, that is char. So char refers to the character. So char Arduino data, and scroll down here. We have serial baud rate, and we are reading the serial info. And again, we are sending it back to the next Arduino. And if we select the first Arduino code, so first Arduino, it is considered as transmitter, which is about to send the code or send the data. And here serial print, it is sending number 9 with every 1 second delay. And that should be visualized in Arduino 2. Here you need to get number 9, and it should be printed in the serial monitor. And we have already discussed regarding this here, like what is the meaning of the serial begin and what is the meaning of this baud rate. So this is the speed at which both the devices get communicated. So let's run the simulation. So they are connected, and if you see here, now we are in Arduino 2. Now for every 1 second, you are receiving the data, like 9. Number 9 is received from every 1 second. And if you go to Arduino 1, so here for every 1 second, it is printing the data. So, but how about the thing like it is not clear, right? So let's make some more clear. Let's stop the simulation and write detailed serial dot print, right? Tx from R1. R1 is what Arduino 1. Let's say UNO 1. Tx from UNO 1, that is sending us number 9. And in Arduino 2, print, and then let's write UNO2 UNO data. So in Arduino 2, you will have the data received UNO data, UNO1 data in UNO2. So right now again, let's start the simulation. So for the first time, UNO data in UNO2 is some undefined data. UNO1 and UNO2. Correct. So you see, for every two initializations or two prints, it is the data is being fetched from the Arduino one. So for every two instance, there is a null data, that is no data received, because this is receiving for every 1 second, and here it is sending for every 500 milliseconds or like that. And you see here like, so here we have the number 9, but the thing is like, let's do one thing, let's improve the code to understand it. So let's send the not only one, let us initialize int count is equal to 0. So for every delay, let's send the increment of the count. That is very positive, like positive to understand. So count plus plus, let's start 0, next is 1, next is 2, and let us visualize it in Arduino 2. So in Arduino 2, you see UNO1 data is received and displayed in Arduino 2. So in this way, the data is transmitted from Arduino 1 or this device 1 to device 2 using UART protocol, that is Universal Asynchronous Receiver and Transmitter Protocol. And you can even increase the speed. So I don't want this delay, let me remove it. And in Arduino 2 also, I don't want this delay, let me remove it. And let's start both the Arduinos. And you see the change is very fast. Here you see you have 568, but whereas here you see you are almost at around 45 and 6, that's it. So that's the reason why we will have some delay and to ensure that we have received proper data. So instead of having 1000 delay, we need to at least have 200 milliseconds as delay. So let's go here and let's make it 200. And let's start the code. So in Arduino 1, it is at 25. So let's select Arduino 2. Still here we are receiving 23, 20, maybe. Again, so here 0 and 1 and 2. And whereas if you go for Arduino 1, it is almost crossed the 57, 58 like that. And if you go for Arduino 1, still it is reading number 4 and 5 and 6 like that. And it will continue after it will continue up to whatever the value that is being printed here. So that is the reason why we need to match two things, that is the transmitter side baud rate and the transmitter side speed of data that is sent, and whatever data that is sent here, the same baud rate or the same delay should be applied at both the uh, endpoints, like at the TX side and the RX side. So let's make it this also 1000. Now you will get the proper data. Like in Arduino 1, you are getting 1, 2, 3, and 4. If you go here, you will also get same kind of data. 3 and 4. So this is the UART. This is the connection of UART. Right. Then next point is we need to look at the next protocol. One is UART. The other one is I2C. So we will also call it as I2C. So before undergoing the communication protocol, let's understand with the device. So the device that you see here, this is a 16 cross 2 LCD display. So this is a 16 cross 2 LCD display. So it comes with a I2C module behind it. So this is the I2C module. So here using this I2C module, we will send the data from any microcontroller board to this chip, and this chip will convert that data into digital form, and that data is being printed here. So what is the term 16 cross 2 LCD display is like? So it has 16 columns and 2 rows. 16 column and 2 row segmented display it is. So even we'll have the, let's see if we could find in Tinkercad. I think
Sir, one
we
kind
have.
is that whenever you're showing the video, sir, can you please stop the sheet?
So this is the LCD display we have here. So instead of going with the hardware, let's do it as with the simulation. Let me take the new Tinkercad file. Circuit, create a new circuit. Correct. So one I2C, let's place to here. And the most important thing is like we need to connect the pin. So and like you see, we should not like say this device or this peripheral, it has VCC ground, and VCC is rated for 5 volts actually. And if you don't know, just Google it regarding this I2C 16 cross 2 LCD display. Then you will get the voltage, operational voltage rating of this device. And before continuing with any of the sensors or any of such kind of external peripherals, the most important thing is like the first point to be considered is like you have to know what is the rated voltage and or operational voltage of that uh, equipment. So here I'm sure like I have already worked over it. So this is 5 volts. So let's connect it to 5 volts. So connected to 5 volts. Let me make it red. Then next one is just connect the next one. Next one to ground and make it black. So SCL. Here SDA. So SDA, let's connect this SDA to A4. Yeah. Let's connect it to A4. Let me make another color orange and SDL to A5. So, right. So this is the connection diagram of 16 cross 2 LCD display. And the thing is like maybe sometimes we may not aware of the how to code this LCD display. So at that point, just go to this file examples and you're gonna just check out do you have any kind of library like LCD I2C LCD display. So I do have, but what we will do, we will start from the beginning. So let's go here. Let's go to the Chrome and search for I2C LCD library. I2C LCD library. Arya. So right, here they have the library. So yesterday I have shown you like how to download the library. So here they have the inbuilt library. So let's go to the library section in Arduino UNO. Get manage libraries. So we need to wait. Yeah. So let's paste it here. Liquid crystal. So liquid crystal, there is a liquid crystal and we need to have I2C. Yeah. So liquid crystal I2C. So we have you can install this or else the best option is just download it from the GitHub. So the most trusted one is to download from GitHub. So below they have provided here. Just download it from here. You can download it and import like we have done yesterday. So I'm not going to do it because I already have it. File. If I go to examples, here. So let me upload a hello world. Let's see this. Let's upload hello world. So this is the sample code to be considered here. So in the code section, so here we have the external library, the simulation and expectation. Okay. So following the same circuit, let me connect the circuit with my hardware device. So I'll do it very fast. 1, 2, 3. 1. So here next I'm going to connect the data pins. So let's say we have SDA and SCL. So yellow is the SDA. So that SDA should be, so that SDA should be, can you able to see my mobile video?
Sir, please
Hello?
screen share, sir. Sir, can you hear me?
Yeah, of course.
Yes, sir. Surya,
Yes.
sir. If you are showing anything on the video from the mobile, please stop the screen.
And regarding there is a, here we have common.
Sir, we are not able to see the video, sir. Please stop the screen share. Yes, now we can see the.
Right. So here we have done the connection, but you see the LED, there is no background LED because there is a terminal left. So we need to short this terminal using a female to female jumper. So let me take the female to female jumper. There is female to female. Or else let's just short it. So if we just short it, yeah, I got a female to female. Just connect it here. And then next we'll connect this. Right. We're done. And let's upload the code into the physical Arduino. So that we are just compiling the code. So once the code is and it is uploaded, and we need to adjust this pot or this knob here. So let me adjust. సరే సరే వదిలే కానీ ఆర్డినో యూనోలో ఇది కాదా మెగాల ఐటీసీ పిన్లు అసలు yeah, so I'm just connecting again.
Sir, we can't see the video. Yeah.
Wheel ground 5 volts. Let me connect the VCC. Okay, and then let me connect SDA here, and orange is SDA, so let me connect the SDA. Right. Let me adjust the knob, reset it first. So we have 2-3 displays actually. So right. So previous we have this display, so it is not working, and now we have just changed the display, and this display is working fine. So now you see. So now you see. Just leave it. Right. So we have written hello world here. Now you see there are. Let me make it dark. Actually, you can able to see why it is called as. Yes. Now you see. You see, I have just made the contrast high. So you see here, total in the column, you will have 16 columns and you're going to have 2 rows. This is the reason why it is called as 16 cross 2 LCD display. So let me make it light. So you can change the contrast using this knob. So I'm just changing this knob. So, right. Now it is okay, right? So so with this, we can able to display a user like any kind of data. So let me do one thing. Let me upload another example. So let's say in the same example section, we're gonna have one more thing. So in the same example, let's go file examples and check out this new LCD. And you see here we have blinking cursor. This is the another example here. So let us upload this. So you see that this is another form like the cursor blinks. So no cursor blink and cursor blink state. And we will have one more example. So let me have the final example of this I2C LCD display. So here this has some special actions. So in this LCD display, what I will explain this final code to the so it's being compiled. So now the thing is like whatever I enter here in the serial monitor, you can see in the screen. So here in the serial monitor, that will be printed here. So A and enter. Then next I am giving B, enter. C, enter. D, F, enter. So I am printing some random character and enter.
Sir,
So
Suresh sir, Surya sir, we are not able to see your video.
I'm just adjusting the brightness again.
Surya sir, we are not able to see what
Okay. Now you can see, right?
iPhone.
Right. Now I'm printing like I'm entering my name in the and here. So you can, this is the another kind of example. So now let's check out how the code works actually. Stop the video. Right. I'm stopping the video in the mobile and just continue with the screen share. So
Whatever you show.
in the screen share, you can able to see the code, right? So here we have this special library that is imported, liquid crystal I2C LCD.h, and here we're gonna have the library declaration and the variable declaration. This is the data address, the LCD address. It is 0x27, and you need to mention the type of the LCD, that is 16 rows for 16 columns and 2 rows, 16 cross LCD display. So then your LCD is initialized, and it has default pins. Like in Arduino UNO, you will have A0, A4, and A5, and in Arduino Mega, you're gonna have the SCL and SDA pins separately. So those are I2C pins, SCL and SDA. Then in void setup, we are beginning the LCD.begin, and we are starting the background light, and we are also begin the serial baud rate. And in void loop, if the serial dot available, that means I am trying to enter a data in the serial monitor. Here I am trying to enter SURYA, and if I hit enter, that data will be available in this method, serial dot available. Wait for 1 second and then get the data and serial dot write. Oh, sorry, LCD dot write serial dot read. Get the data from serial and print it in the LCD display. So that is what we have done here. So this is the example, and you will get this example in from examples and Arduino Liquid Crystal I2C library master. So this is the serial display or hello world, custom characters, and so on. So you have multiple examples, 4 examples here. Using these examples, you can easily know and you can easily learn regarding the LCD, I2C LCD display. So this is how I2C communication. And let's see the another example, custom characters. So how this custom characters looks like. And again, uploading this custom characters code. So the custom character code. So it is giving random codes. So custom characters is, it's like it can, that means this is the example that it can be able to visualize any kind of data. So you see, it can able to visualize the alphabetical information. It can able to visualize the mathematical like multiplication, subtraction, and division, and it can able to visualize the small case, and even it can be able to visualize the special characters also. That is what this example says. So special characters and other languages. So this is some Chinese language.
Sir, whatever you're
So
showing,
this example shows the custom characters displaying in the I2C LCD display over I2C communication protocol,
sir, whatever you're
right?
showing,
So let's see some industrial grade now. So just a minute. I'll move the setup aside and bring the next device. That is, so here I just got. So with the OLED display, now let us work on with the same example. So let me connect first the OLED display. So OLED display is not available in the what so called Tinkercad. So that is why I'm just connecting it manually. OLED display is also based on the I2C protocol. So VCC ground. So let's search for VCC. So 5 volts. Okay, 5 volts is already occupied. 3.3 volts. And connecting to ground. Next one is SCL. So SCL, let me connect to the A4. So here we need to connect to the yes. Do you have any questions?
अशी चालू आहे चला आता ते आवाज कमी केला तर लोकांना వచ్చిందా
Sir, please continue. If there are any questions, they will leave it in the chat box and we can answer it from there. Guys, if you have any questions, you can leave it in the chat box and we will answer it at the end of the
అట్లా రైస్ లో ఉంది వేది నా హ్యాండ్
So can you hear me? Actually, there is a problem with my browser.
Yes, sir, we can hear you.
Okay, okay. So next one, we are going to look at the NRF, the industrial standard device. So I'll get the device. So the NRF device is used to virtual or the wireless data transfer. So here you can see this is the NRF module. This is the NRF module. So this module is used to transfer data wirelessly, and we have built a project. The project is like using this knob or using this knob, we need to perform a vehicle, that is vehicle control system, that is forward motion, backward motion.
Your video, sir. Please share the please stop the screen share and then we can see your video.
Okay.
Yes, sir. Now the video is visible.
Okay, fine, thanks. So, so the next one is we are looking like the wireless data communication or wireless data protocol. So here we are undergoing with a wireless networking device, that is NRF module. So this is the NRF module which works on a radio band. So here this NRF narrow radio band, actually NRF is narrow radio frequency. So with this module you can transfer data wirelessly to the other end. So this is a transmitter module, and we're gonna have a receiving module at a in a device. So actually it is in a vehicle. So the task of this system is to control it using this knob. Like we need to move the device forward, and we need to move the device backward and left and right. So here this is STM32 board. So it's STM32 blue pill microcontroller. You can even search this. This is the much more low cost and industrial standard board, that is STM32 board. It's the name of this board is blue pill. So using this blue pill board, we just build this application. So this is the transmitter. So it is now we are designing it as a remote. Then we should have a receiver, right? So I'll show you the receiver.
Sir, we can't hear you, sir. Sir, you're not audible. Surya, sir,
What happened?
You're not audible, sir. You were showing something with the.
Yes, yes. I'm not audible. Can you hear me?
Now you are audible, sir. Just a while ago, when you were showing the other project, you are not audible. Can you repeat that?
Okay, okay, fine. I'll do that.
Yes, sir. Thank you.
Yes. So now you see here, this is the transmission, like this is the remote. So here we're gonna have our transmitting model. So this is NRF transmitter. So here this transmitter tries to send data from here. So what is the data that we are trying to send? So basically it's a knob controlled remote. So this is forward direction, reverse direction, and left and right. So here it is being controlled with a microcontroller called STM32. So this is STM32 based microcontroller, and the name of this board is Blue Pill. So it has been called as Blue Pill. This is a STM32 variant, one of the cheapest and the industrial standard board. So here we need to control the device wirelessly. So that is why we are using NRF transmitter, and this is the NRF receiver. So this is the transmitter and this is the receiver. So here in at the receiving station also we have another NRF. So the data that is sent from the transmitting station, that is received at the receiving station here, and the data that is sent from there is being parsed or being processed by the microcontroller or STM32 Blue Pill board. So this board, and it gives the supported signals based on the data that we send from here to these motor drivers. And if the signal received by the motor drivers are satisfied, then these motor drivers will control all the four motors here. You see there are four motors here. Basically these are gate motors, high power gate motors, and these are high powered motor drivers. So and the entire system is being supplied with the SMPS power supply. And let's see the working. So we just powered on. We just powered on the transmitter at here, and we have the receiving car at here, and it is also been powered on. Okay, with SMPS. So let's see the working. So you see, based on the knob, so I can able to control its action. So based on this knob, you can see now. So this by this kind of wireless transfer, we can implement the rover operation directly. So we can control it at longer distance also. I'll just park it at that place and let's continue. That's it. So this is how. So I think you have seen the working of NRF. So let us now see the basic functionality, sorry, basic code. So for NRF communication, we're gonna have two codes.
Sir, your screen is
They
not.
are the transmitter side code and the receiver side code. So I will share the
Sir, your screen is not visible. Can you please share your screen?
I'll share an image if possible in chat box. So let me share. I think there is no option. So I will share the reference link actually. So you can follow this link to set up an RF communication. So I have sent in the chat box. And coming to here,
Sir, could you please share your screen? And also we have a query from Namita, sorry. Sir, you're not audible or your screen is not visible, sir.
so regarding the second one, I am just sharing the link. So we have, I'm just sharing the link regarding the second motor. So it is motor shield VNH 2SP30 motor driver. So it has 14 amps and peak voltage, peak current rating is 30 amps. So regarding the question that you have asked here about the motor, so so this is a link you can even purchase at here. So I have shared the NRF example. So let us check the codes actually. So this is the transmitter code of NRF. So here NRF has,
So,
okay, I have a comment actually. Can you? Yes, we have NRF robots available, but this is a specialized NRF bot that we designed. So this we are designed for medical purpose for dialysis machine. So above that we will place a dialysis machine, and that dialysis machine is being carried out over the machine without manually shifting everything. So everything is over this device, and they will use remote to navigate within the room from one patient to other. So that is the reason why we build that. So here, this is the example. So NRF. Yeah, NRF is narrow range frequency, and I'm not sure that it is available for wide range. But I think as of now, the test we have done, it can only come up to around 120 meters. That's it. That is also open air, not in the closed. If you are in closed area, you may get, like, if there are some distractions in between, you may get for around 100 meters or 80 meters. But we have tested in open area, it comes for around 120 meters. Okay, fine. So here, coming to this NRF, so NRF has NRF24L01 library that is available. So let's go to the examples. Let me check NRF.
Sir, are you showing anything on the screen? Because we are not able to see anything. If at all you are showing anything on the monitor, please share the screen, sir.
Yeah, just I am a bit confused between my mobile screen and this.
So you were saying about, you were sharing about the links and the items that you were saying just now.
Yes,
So
yes,
you were saying
yes,
certain examples, and you were saying you wanted to show some more examples. So please share
yes,
your
yes.
on screen, sir.
Okay,
Yeah.
fine, thank you.
Now we can see the screen.
So here we are looking at the example code of NRF. So here NRF 24L01. So here we'll have this libraries LRF24L01, and we need to begin the configuration pin, that is CE pin and CSN pin. And for each NRF module, because NRF module is a open source and you can have multiple NRF devices, for each NRF device you can assign a unique identification number here. So as of now, I'm with an example. I just use this number, and in void setup, just begin the radio. And here you need to write with the radio. We are making it as a transmitter because this is a transmitter code. So this line of this object or this method will make it as a transmitter. So open write at it at this address, and then PA level. So the PA level should be minimum, and we are stopping to listen because this is a transmitter, so it should not listen to any kind of incoming sources or incoming data. So that is why we have stopped the radio dot stop listening. We have stopped the listening, and now it is purely in transmission mode. And now here transmitting the data, like we need to transfer the buffer data, not the raw data. So that is why we are not transferring the string type text or the direct raw text. Instead, we are converting it into character buffer. So this is char, and here these symbols are represented as buffer data. So and then radio dot write. So we are writing the buffer data, and the second parameter or second point, this point indicates the size of the buffer data. So for example, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here you will get the hello world char buffer data, and here you will get the number 11. And we wait for 1 second, and again this loop will continue, and further the data is being transmitted directly. So using the same concept, we have read the knob information like analog data, and we have sent that analog data in the place of hello world, and we will parse that hello world data at receiving station. So let's see the receiving code also. So right, this is another example. This is the example for receiving. So in the same way how we have configured the transmitter side, we also need to configure at the receiving side. And here at this receiving side, we need to initialize 7 and 8 as CE and CSN pins, data pins.
and address, same address as of the transmitter. And then here you see here open read. There you have initialized open write. Here you are initializing open read, which means you are making your NRF as receiving station. And here you are start listening. So there you have stop listening. Here you are start listening. And then you are reading the information, like when radio dot available, radio dot read the buffer data that is received into this text character buffer with the size. So for example, there we are sending size 11. So here you will get 11, and here you will get the char buffer. So that buffer is stored in here, and that buffer will be print as output. So now let's see the actual code. So now let's see the actual code of the NRF that we have written. So if you want this code, you can find it in the examples directly, or else I can share it in the code is available in the website link that I have shared you. So that website has all the functionality of NRF communication. So let's see, let me explain you how the device is working. Right. So here, this is the medical NRF transmitter code. So in this transmitter code, so we have SPI communication protocol and NRF libraries included. And here we have servo.h to create PWM signals. So because the driver that we are used based on PWM signals. So those drivers works based on PWM signals. So here RF 24 is being initialized on PB0 and PA4 because PB0 and PA4 are purely based on the STM32 blue pill board. So if you want to understand this kind of what you call pinout terminology, then you need to browse for blue pill, STM32 blue pill pinout. Just go to images and let's say, let me choose. This is good. So if you go down here, right. So here you see the STM32 blue pill board. So STM32 F103. The name of the STM32 blue pill board is STM32 F103. So the STM32 F103 board pinout is being displayed here. So with this pinout, you need to consider the what you call pins. Like you see in Arduino, we will use digital pins as 0, 1, 2, 3, 4. Whereas in STM, we need to use as PB12, PB13, PB14, like that. And for analog, we're gonna have PA1, PA2, PA3, and PA4. So these are analog pins here up to here. So they mentioned ADC0 to ADC9. These are analog pins here. And rest all other are digital pins like PB0, PB02, PB12, and some of them have special purpose pins also. Like here you're gonna have PB10 and PB11 is SCL, like this I2C, and you're gonna have PA3 and PA2 are TXRX. That is, these two are UART pins, and these two can be again ADC pins also. So it has multiple functionality. So refer to this pinout. Not only this, for any board, first thing is you need to refer to the board's pinout diagram. Then only you have to undergo all the connections and functionality of the board. That is very, very important. So right. The next one, where we are. Yeah. So that is the reason why there in Arduino UNO, the example that I have sent you right now, we have used 6 or 7 digital pins. Here we are using PB0 and PB4 pins. Then you see the address. The address is different. You see, for example, in previous example, we have tried for 0001, 0x00001. But here, because ours is an industrial standard one, like no one should override our communication protocol. That is why we have gone for some hard address. Like no one should able to find out this kind of address. That's why I have gone for some secured address. So the next we have some variables included in here. So these variables are like controlling the driver INA1 or INA, INB, and PWM pin, speed of the motor. For next motors INA2 and INB2. So this is for the first one, first set of two motors, and this is for second set of two motors. So we have two drivers. With each single driver, we are controlling two motors. So here, these three related to the first two motors and first driver, and these are related to the second two motors and the second driver, right? So here, these are the this is a variable which holds the forward channel signal and backward channel signal, right channel signal, and left channel signal. And here we have defined the servo PWM signal generator variables. So servo and channel 1, channel 2, channel 3 up to channel 7. So in setup, we are initializing all the pins first. So first we are initializing the serial board, and next we are initializing the pin modes of each individual pin. So for the first driver, we are initializing INA, INB, and PWM pin. For the second one, also we are initializing the same. And then we are connecting the driver pins at servo channels. So 2, 3, 4, 5, 6. And then we are finally initializing the radio and making it ready to read the data. And then we are start listening, so that this data is okay. This is the receiving code actually. So this data, and up to here, the transmitter side also will be same up to here. So here, here start listening, and by default we are making the 4 channels with some standard measured PWM signal or value. And then finally, in the loop, we are ready to receive the data. By default, the speed is set to 120. When the radio or when the transmitter is sending some signals, then we are reading the signals here, and we are breaking down and parsing the signals here. Then we'll get all the numbers, because we are splitting the data that is sent from the transmitter side, which is separated by is equal to, and that has been broken here into individual parts. So the first part of the signal is channel 1 value, second part of the signal is channel 2, and third part, fourth part. In this way, we're going to have 6 channel values. And then based on the channel values, we are mapping the forward channel value, backward channel value, right channel, and left channel. And finally, we have written the if then else condition. If channel 1 is less than 400, we need to move the vehicle to the right. If the channel 2 is less than 400, we need to move the vehicle back. And the channel 2 is greater than 600, we need to move the vehicle forward. And if the channel, if the channel has default values and the transmitter also sending the same values, then we will stop the vehicle or will stop the motors. So the methods helpful, like the methods used to drive the motors, are declared separately. So that is why we are just written like vehicle.forward and vehicle.stop, like that. So in vehicle.forward, you're going to have the motor 1, motor 2, both drivers forward, both drivers backward. And if you want to go right turn, the left side or the right side motors should turn to the right, and left side motor should also turn to the right. But the thing is, like, right side motor should turn somewhat slower and left side motor should turn somewhat faster in order to take a sharp right. So that thing also been written. And in the same way, we have just swapped the left rotation also. So this is the receiving side code. So now let's check the transmitter code. So transmitter code will be very small and very simple to understand, because it does not have any kind of control. Instead, it has only the data transfer. So you see here, it's the same code up to here. We need to initialize the libraries. So initialize the RF24. Then initialize the channels, channel values. Same address should be considered. And then finally set up. So radio.begin and radio.open right which initializes for transmitter, and stop listening, which means this device is not allowed to listen any kind of incoming data. And we are initializing with the default values for each individual channel up to channel 7. And we are reading the knob information that from PA0, PA1, and PB12, PB3. So we are reading the channel information from the knob, that is forward motion, backward motion, left and right. And we are just converting it like this. So 0 is equal to, after is equal to the second channel value, and after another is equal to third channel value, and after another fourth channel value, and finally fifth channel value, and so on up to sixth channel. So all the channel values is organized like this using string concatenation method. And then finally we are writing the data. So we are transmitting the data. So this data is transmitted to the receiving station, and based on the data that we transfer here, the receiving station will parse the data, and based on the necessary condition provided, it will perform the action. So I got a message. So in the address, yeah, of course, this is the hex code value. So this is the hex code value.
Sir, we have a question.
So instead of going with the normal 000x and everything, so this is the hex code value, and the last LL is the suffix actually. So which might imply like it's long integer, and in some programs like C or C++. So when we convert the characters starting represent the hexadecimal value, and the last LL is the suffix which represent this as the hexadecimal value. So right, do you have any questions? So do anyone have any doubts? And there are many sensors in the market. So I'll show you some of the sensors which are used. So just I'll tell them what is the use of those sensors. So I'll just stop sharing. So this is a 2-channel relay. So this relay is used to control any AC voltage appliances. Like this is operated based with the any microcontroller. It is operated based on 5 volts. This relay is operated based on 5 volts, and using these relays, you can control or operate the AC line voltages, which is up to 240 volts. That means you can even control your household lamps or electrical appliances. And
Sir, we have a query from
so
Kondaya.
let's see some more. So unlike NRF, we're gonna have one more device, that is LoRa. So this is the LoRa sensor or LoRa module. So both for LoRa also you're gonna have LoRa TX and RX. So this is LoRa RA0. This is LoRa RA0 AI Thinker module. So with this module you can undergo with LoRa data transfer. So one should be like LoRa transmitter, and you're gonna have another device that should act as LoRa receiver. So with this LoRa, you're gonna transform the data or information for longer range at a lower bandwidth. So I suggest you to use either go with Amazon, or you can even visit Robo. Actually, Robo is a very famous electronic supplier. Right. So next. So this is one more Robo, ROBO, robo.com. So we're gonna have soil moisture sensor. This is resistance based soil moisture sensor, and so this will measure the wetness or dryness of the soil. So you can measure the wetness of the soil. So with this you can perform a automation like plant watering automation system with this sensor. So this is resistive type, and it may be corrosive actually. After a few days you will see that this plate get damaged. So for that there is a solution in the market. So that is capacitive type sensor. So this is the website Robo. So Robo has maximum electronics available. So capacitive soil moisture. Yeah. So this is the one. So the thing that just you have seen is the resistive type soil moisture sensor, and here this is the another one which is capacitive soil moisture sensor. So it does not have any kind of corrosive element. You have to dip up to this level, then it will measure the soil moisture directly. You have to dip up to this level. So this functions based on the capacitance of the ground, right? And so for learning, we need to we have some other sensors like so for any human automation we need to use this kind of sensor. So this is a PIR sensor. So it works based on the thermal intensity of any living being. Like this is most importantly, it is used as the motion detector actually. So it is a motion detector. So this is called as PIR sensor. So this also can be connected with Arduino. And just now you have seen this relay light. So this is the mechanical relay. So it has a mechanical option. It is a mechanical functionality. So where you will have a mechanical arm which is placed in between the electronic coil. So when the supply is given, it behaves as electromagnet, and based on the supply given, the relay or the coil, the arm, that mechanical the arm will move up and down, which makes the circuit open and close. And this is the solid state relay. So it is we call it as SSR. So this solid state relay does not have any kind of mechanical movement. So instead it has all the electronic circuit which will turn on and turn off the output of the device. So this both will works in the similar manner, but the thing is like this is mechanical and this is purely electrical. So this is solid state relay. The next one is, so this is one more device. So here you see you can see this, right? So this is the industrial grade temperature and humidity sensor. So this is the industrial grade temperature and humidity sensor. So here it measures two things. So especially the specialty of this sensor is like it can measure the ambient temperature, that is the atmospheric temperature and humidity. And this is the ppm or the carbon dioxide level reading sensor. So it is ppm sensor, and you're gonna have so a PCB, and with this PCB we have same SSR, solid state relay, which has 5 amps current rating. And here you're gonna have high link. So this is high link. This is the power module. So this is a device that is built for, so industrial grade device that is built for some industry or the warehouse actually. So there we are going to monitor the temperature, humidity, and the carbon dioxide level. So in this way, we're gonna have many electronic and many projects and even many vendors. If you check out RoboSet, what is that?
Sir, your audio is breaking.
Uh, can I know what you are asking? What does it mean? Hello? Hello? Can you hear me?
Yes, sir. Now you're audible.
Can you hear me? Hello?
Yes, sir. I can hear you. We can hear you.
Okay, just if anyone have any doubts, please let me know in chat box and now
We
we are
have
not able.
from a student. The question is, what is the name of industrial temperature sensor?
So this
So you're not audible.
just a second, I'm just taking it out. You mean this thing? Okay.
Yes, sir. The same thing that you're showing.
This is AM2305. The same name of the sensor is AM2305. So this is the industrial grades temperature and humidity combined. Both it can measure both temperature and humidity. AM2305. 2305. And this is the ppm sensor, and the name of the device is ppm sensor. It is used to measure the carbon dioxide level in the atmosphere. So both measures the atmospheric atmospheric values. This measures the temperature, humidity, and this measures the carbon dioxide.
Yes, sir. Thank you. Sir, there was one more question. Can we extract the code from ESP8266 module?
Some methods says that we can extract, but not that easy, because the ESP32, whatever microcontroller stores, everything is in binary form. So there may be ways, but I'm not sure about it. But I have heard like we can do, but till now no one has done it, and no one even focused on that kind of issue. And even if they extract also, that is in binary form. You are not allowed to change anything. Instead, just you are going to take the code and you can down maybe upload into your devices. That's it. There is no choice of editing the code.
Okay, sir. Thank you. For now, that's all, sir. We don't have any pending queries from the students in the chat box.
Okay.
Yeah. So can we call it a day? So, guys, before calling it a day, we actually provide a course on embedded systems. So if you are interested, you can get back to us on our number that is being shared on the chat box. And please also join tomorrow's session, right? We will learn more on this. And thank you so much for your time for today. And please also give your valuable feedback, and the link has been shared in the chat box. And I would like to ask once more, does anyone have any more queries? Okay, thank you guys. Thank you so much. Thank you for your time. See you tomorrow. Thank you, sir. Thank you for your time and your valuable information.
Okay, ma'am. Thank you so much. Right.
Thank you, sir.